Hello, everyone. We appreciate your time today. We've got a lot to cover, so let's go ahead and get started. nVidia has been offering professional products for 20 years, and PNY has been partnering with them for about the same length of time. The point I'd like to make is we really do appreciate what you folks do for PNY, and frankly, what you're doing for the community at large. From the buildings we live in or work in, from advances in AI and data science to radical breakthroughs in product design, to scientific and technical advances that allowed us to develop vaccines for a pandemic in record time, to advances in bringing fusion energy closer to being a reality, to the latest blockbuster movies and CAD and CAE. What you folks do with the cards you purchase from us and the systems you build that utilize those cards in some cases are very important and touch every facet of our daily lives. The NVIDIA Professional Compute Platform is broader and wider than ever. It spans the gamut from thin and light high-performance notebooks with NVIDIA RTX technology to incredibly powerful multi-GPU desktop or desk-side workstations, all the way into the data center. And of course, the use cases from rendering to virtualization, particularly in today's work from home or remote work environment, to advanced interactive and fluid CAE simulation much earlier in the design process are critically important, as are improved computation capabilities, data science and analytics, and advances in AR, VR, and XR. A topic we'll be talking about in future webinars, NVIDIA Omniverse Enterprise, is an exciting new platform that really does bring all the power of NVIDIA RTX technology into a much more seamless, fluid, and predictable environment for complex distributed graphics workflows. And again, we'll be talking about Omniverse later this year and conducting webinars, probably more than one, frankly, on it over the course of the year. Now, NVIDIA released the Ampere microarchitecture, which is, again, kind of part of their cycle of refreshing the underlying, technology that goes into NVIDIA RTX products, either every year or at most every other year. So we've got second generation RT cores, third generation tensor cores, much more efficient CUDA cores. Of course, we've moved on to PCIe Express Gen 4, and NVIDIA continues to make advances with NVLink technology. To net it out, really, what you'll see is with the second generation RT cores, roughly a 2x improvement in rendering performance, the ability to do things like motion blur. The third generation tensor cores up to 5x training improvements. They also offer a new feature called structural sparsity, which you'll see on some of the performance slides we go over later, which can offer significant performance boosts. And the CUDA cores in NVIDIA's constant quest to improve performance per watt offer twice the efficiency. Of course, Gen 4 PCIe offers twice the bandwidth, and with NVLink and at the high end with the RTX A6000, you have the ability to go up to 96 gigabytes of GPU memory. The RTX A6000 brought Ampere to professional graphics. It still is powering the world's highest performance workstations. I just put this slide up briefly. I'm not going to go through all the specs. You'll get the slides as Tanya mentioned, so you can peruse them at your leisure. But a few things I'd like to point out is notice the steady improvement in image quality, the increases in resolution. And in this case, it's kind of 8K across the board, but things like better color bit depth for HDR images or higher refresh rates. Look at the improvements in FP32 performance. Look at the fact that we've moved on to Gen 2 or Gen 3 RT and tensor cores that offer significant performance advantages. So it's been kind of rapid product iteration that frankly CPUs just don't match. But until now, the RTX A6000 has been splendidly isolated, and at GTC we were extremely pleased, along with NVIDIA, to see the announcement of the nVidia RTX A5000, which is a new full-length, full-height dual slot width card that we like to say offers perfectly balanced features and blazing performance. Again, high-level specifications, won't go through them all, but look at the increase in CUDA cores, Tensor cores, RT cores, the FP32 performance, RT and Tensor performance. Very impressive NVEC, encode, NV, NVEC, encode and decode capabilities. And, extremely high performance memory bandwidth and memory subsystem, and NVLink interconnect capabilities at 112.5 gigabytes per second, roughly twice that of the prior gen RTX 5000. Again, you'll see a steady march of progress here from gen to gen, and I actually go back gen -2 because we'll be showing that on performance charts. But we're up to 27.8 teraflops, the gen 3 Tensor cores, gen 2 RT cores, 24 gigabytes of GPU memory, GDDR6 with ECC, so a significant improvement there, significant improvement in memory bandwidth. The ability to drive 4K, 5K, 6K, even 8K displays at HDR, 60 Hertz, and only 230 watts power consumption, so significantly better performance than the Gen -1 or Gen -2 cards, but the same power envelope. If you look at it from a performance improvement for specific disciplines, some very impressive numbers, up to 60% faster than the P5000 for doing CAD, up to 27% faster than the RTX 5000 for doing CAD. If you're into digital content creation, M&E, up to 70% faster than the P5000 or 30% faster than the RTX 5000. And if rendering is important to the markets you serve or the customers you sell to, 6 times the performance of the P5000 and up to 2.5 times faster than the Gen -1 RTX 5000. Some customer testimonials. I'll go through these fairly quick because you'll have them in the slides, but there are something that you could quote to folks, customers you encounter in similar markets or use cases. One is Diamond View, which is a leader in virtual production, which most of us first became acquainted with The Mandalorian. But I'll actually point out it's been around since the 30s with rear projection film for movies that had scenes of people in cars. But Diamond View is a leader in this market, and they were extremely impressed by what the RTX A5000 allows them to accomplish. Another example of a leader that had early access to the A5000 and was extremely impressed is What a Digital, who's been behind so many wonderful movies, starting with the Lord of the Rings trilogy and so many others. They are really looking at standardizing on the RTX A5000 as their board of choice for their workstation user community. In a more traditional realm, CAD, Aztec Industries makes very industrial grade equipment that goes into facilities like concrete manufacturing. What's interesting is not only did they use the A5000 for CAD, but they also used it for simulation because they're working with aggregates, which you could view as many particles, in this case gravel, that has to be correctly mixed to form durable and long-lasting concrete. So they not only used the A5000 to do the CAD lifting, but they also used it to do a lot of the heavy lifting for CAE simulation early in the design process to validate their products before they had to cut metal or start building prototypes. Woods Bagot is a global architectural firm and considered a leader. And again, the story is very similar. When they see what the nVidia RTX 5000 offers with advantage applications like Chaos Vantage and nVidia Omniverse, they're making it pretty clear that the A5000 will be a huge part of their future product acquisition plans. If you look at freelance design, which is a very important market to sell into, David Bayless Design, again, focuses mostly on automotive, but they branch out into some other areas. They were extremely impressed and pitted the RTX A5000 against the Gen -1 RTX 6000. It performs better thanks to Ampere and the later generation CUDA and Tensor cores. Finally, another one is Thomas Burke and others. They're kind of a general purpose shop for creating very sophisticated rendered imaging for customers. And they literally considered the A5000 a game changer when they were given access to it. I'm showing an example of one of their renderings of some RCA vacuum tubes. And they deliberately went for a kind of an atmospheric effect here. But this is indistinguishable from what you'd get with a digital photograph, and much easier to do given the current situation we all find ourselves in. In terms of performance, I'm showing the A5000 relative to the Gen -1 RTX 5000, the Gen -2 P5000. If you have a customer base, installed base that's on the P5000, 2.3 times faster with the A5000, which means if you're selling boards, you've got an upgrade opportunity. If you've sold workstations and not quite ready to upgrade that workstation, perhaps you could offer them a suggestion to give it a midlife kick by upgrading the graphics to RTX A5000. If we look at rendering performance, again, Gen -1, Gen -2, I've normalized Gen -2 to 1, up to 6.7 times the performance. And I'm showing Blender, V-Ray, Keyshot from Luxion. So these are very popular, very widely used GPU accelerated rendering packages, and will give you an idea of the kinds of performance advances you can quote to your customers. Autodesk VRED is very popular in manufacturing, particularly automotive. Again, the difference here is not subtle. If you go back to Gen -2, 10.5 times the performance of the P5000, and about 4.2 times the performance of the Gen -1 RTX 5000. These are very demanding environments where ultimate performance matters, and certainly upgrade opportunities abound, or the ability to integrate them into new systems and offer higher performance options are also on the plate for you as well. Of course, CAD and DCC are kind of still bread and butter markets for these cards. If you look at a subset of spec ViewPerf that focuses on CAD performance and you normalize the P5000 to 1.0, you see a little over a 1.6 performance improvement with the RTX A5000. If you look at DCC, you go from 1.0 to 2.5 times the performance of the Gen -2 product. Again, offering you board upgrade or system upgrade opportunities. AI is becoming increasingly important, not just for folks that are doing hardcore AI, but are using it for, graphics like AI denoising or deep learning super sampling to improve image quality. But here we're focusing on ResNet 50 training and BERT, which is used in a lot of, natural language recognition systems. And we've normalized the performance of the Gen -1 RTX 5000 to 1. And you can see up to a little over a 6-fold performance improvement with A5000. So those of you that are starting to get into this space or have already specialized in it have a real opportunity here. HPC tends to overlap to a large extent with what's going on in the AI community. And here I'm showing AmberMD, NAMD, and GROMACS, which are used in life sciences and molecular dynamics. Again, we've normalized performance to 1.0 in AmberMD. You can see 2.3-fold roughly performance in that application. If you go to NAMD, you see this little tiny red slice where the P5000 went. The P5000 simply was not able to run NAMD with any degree of acceptable performance whatsoever. The RTX 5000 is normalized to 1. You get 1.6 with the RTX A5000. GROMACS, again, a similar story. The P5000 couldn't satisfactorily run this software at all. Relative to the RTX 5000, you get 1.6 times the performance in GROMACS. We're also very pleased to introduce the nVidia RTX A4000. And this is far and away the most powerful single slot width, although it is full height and full length, a professional graphics board that nVidia has yet been able to bring to market. And they worked awfully hard on this card. Again, high level, specifications and features. You'll get the slides, so don't worry about taking notes. But note impressive CUDA core count increases, very impressive FP32 improvements. All the encode, decode features you'd want for video, moving on to PCIe Gen 4. NVLink is not supported on this product, but memory has been taken up to 16 gigabytes, which is twice that of the prior generation RTX 4000, which offered 8 gigabytes. And for the first time in a single slot width card, ECC is available as an option if you have users that simply can't tolerate memory errors because they're doing very elaborate computer-aided engineering or, simulation in physical or life sciences. If I go back a couple of gens, you see the increasing march in progress in memory capacity in terms of Gen 2, Gen 3, CUDA and RT cores, huge improvements in FP32 performance, and still very reasonable power requirements, 140 watts for the RTX A6000. Now, again, if we look at it from a professional workflow point of view, in computer-aided design, 70% faster than P4000, 30% faster than the Gen-1 RTX 4000. In the DCC M&E space, you can expect up to 80% faster than the P4000 running, the popular apps, and about 30% faster than the Gen-1 RTX 4000. For the hardcore rendering crowd, up to 6x faster than the P4000 and 1.8 times faster performance than the RTX 4000. And again, the new Tensor cores offer features like motion blur and some other capabilities that simply weren't available on the Turing products at all. Back to Spec ViewPerf, which again is kind of the gold standard for, benchmarking graphics, up to 2.1 times faster than the Gen-2 product, but you also have it compared with the prior generation RTX 4000. And across the board, not so much with Creo, but with the other apps, you see significant performance advantages. If you look at rendering performance, again, this is all about, how quickly can you deliver the goods? How many opportunities do you have to iterate and explore different creative concepts from your customer's point of view? You can go in and with the A4000 offer them up to 6.8 times faster performance than the Gen-2 P4000 and significant improvements even over the prior generation Turing architecture boards across Blender, V-Ray, or Keyshot. Yeah, and this holds true. We'll get other benchmarks over time. Just because I chose these other three, if your favorite renderer isn't listed, you will probably see similar performance gains. They're simply not subtle in all the tests that either nVidia or PNY has been able to conduct to date. Again, actually the 10.2, this is not an error. The numbers came out exactly the same for relative A4000 performance as they did for A5000. 10.2 times faster than the Gen-2 product. So those of you that specialize in automotive or areas where VRED is popular have a real sales opportunity for boards or systems. AI, again, very similar story. ResNet 50 training shows 4.3-fold faster performance than the Gen-2 product, a significant improvement over Gen-1. Again, in the next chart, TensorFlow, GNMT training, we see a couple little red rectangles. The P4000 prior gen RTX 4000 couldn't run that. In the case of the P4000, it was lack of memory, lack of tensor cores. In the case of the RTX 4000, it was the GPU memory size primarily. But the RTX A4000 can run it. So those of you selling into AI, I'm not going to pretend this is the card I'd recommend you deploy massive AI projects on. But if you wanted to offer your customer base or your installed base or your prospecting for new AI customers that are looking for a board to do early developmental or exploratory work, this would be an excellent choice for you to offer to them. Again, if we look at HPC, and I'm using the same three apps, we used for the A5000, up to 2.3 times faster than Gen-2, and still significant performance improvements, even over the prior generation Turing product. Here's kind of a summary spec view perf that compares the 6000, the A5000, the A4000, all using spec view perf. Again, application performance varies somewhat, better for some than others. But you do see, particularly Gen-2, real upgrade opportunities that you can take to your accounts. I wanted to touch briefly on RTX GPU memory capacity. Again, larger and larger working sets, whether you're doing CAD, CAE, whether you're doing rendering, whether you're doing AI, this simply is tremendously important. And although the RTX A4000 doesn't support NVLink, now that it offers 16 gigabytes, it's up in the kind of territory that, just Gen-1 required a high-end or ultra high-end card to reach. So if you have customers that are looking for 16 gigabytes, you can offer them the RTX A4000 even though it doesn't support NVLink. The A5000 and A6000 do support NVLink, and you can see the range of capacities you can go. And I've also included the prior generation Turing architectures on this card by way of comparison. One nice thing about the Ampere boards is they all share a common set of NVLink connectors. This is true not only for the graphics-oriented products, but also for the data center GPUs like the A40, A30, that also utilize NVLink. RTX for manufacturing and product design has some real advantages. The ability to visualize, use real materials, lighting, physically accurate rendering, lets you take product concepts, lets your customers bring product concepts to the customer or pitch a proposal more quickly and with much higher degrees of realism than they ever could before. Bringing engineering simulation into the design process earlier results in higher quality products, potentially lower manufacturing costs, more lightweight. Tremendous opportunities here for you folks. And simply GPU memory capacity means larger assemblies can be manipulated with full GPU acceleration. And again, from 16 gigs all the way up to 96 gigs, depending on board and whether or not you implement NVLink connectors between the cards. For AEC, again, faster design iteration. Some of that came out in the quotes, the success stories we had earlier. They can simply do far more in less time, which means the designs are more compelling. They have a wider array of creative options. They can show the customer differences in climate, time of day, materials choices. Obviously, this ties into virtual reality. Some 80% of large architectural firms are using VR extensively today. So VR is actually finding more of a foothold in professional graphics than it is on the consumer side of the house. Obviously, larger assemblies with the BIM software that's out there now, doing entire buildings or urban landscapes, cityscapes, or campus projects becomes a possibility with the amount of memory these products offer, and you can pitch them accordingly to your customer base. Media and entertainment simply does incredible things. You can accelerate the product pipeline. Here I'm showing an example of digital de-aging, which is a burgeoning and very rapidly advancing technology. Many of you may have seen it in the last episode of the Mandalorian, third season of The Mandalorian, where all of a sudden we saw Luke Skywalker looking like he did when I was driving around in the black Firebird Trans Am back in 1983. Higher fidelity workflows, obviously, better ray tracing performance, more iteration, more creative options, and more complex renders, more elaborate textures with materials definition library, physically accurate materials, subsurface scattering, accurate refraction, reflection, caustics, all the stuff that goes into ray tracing to make it look so real are available for you to pitch and sell and use to close sales with your accounts. In ray tracing, this looks like a digital photo, nice pose. but is actually a digital human, courtesy of Digital Domain and Ian Spriggs, who actually modeled himself. In a sense, he created a digital clone using biometric information, laser scanning, and other modeling information. I won't play the entire movie, but I am going to let it go a little further until it zooms in and shows you just how quickly you can fill in. And I will say this was actually done on the prior generation Turing products, so it would be even faster with the Ampere boards we've been discussing today. Ultimately, the importance of RTX is about subtlety. Realism is subtle. There are a lot of cheats that have been used in the past with hybrid rendering that came pretty close to looking real. But with ray tracing, particularly as implemented in Ampere with the motion blur and other new facilities, physically accurate materials through MDL with Pixar's Universal Scene Description language to make this more portable. Here's an architectural example using glass. This is thermal glass, so it tries to reflect infrared but lets visible light through. You can see some subtle details inside that building. There's no way hybrid rasterization could fake that. So reality has a high degree of subtlety. Getting past that uncanny valley or the valley of incredulity to true photorealistic results, again, is the core to selling RTX across creative disciplines where visualization and rendering are essential. I should point out, since this, we're talking about pro graphics, the prior generation NVIDIA Quadro RTX products all continue to remain available. So if you've got customers that are standardized on them or involved in projects where for legal or regulatory reasons, this is the card you must offer, they continue to be available. And as with all Quadro products, we'll offer lifecycle management and make you aware of EOL dates, last time buys, and can offer long lifecycle availability for the products